Welcome to the lesson on the periodic table and parts of an atom review. So let's begin. Parts of an atom. An element is a substance that is made up of only one kind of atom. An atom is the smallest particle of any element that gives the element its properties. A compound is a substance that is composed of two or more different kinds of atoms. Subatomic particles are the particles that make up an atom. So this is a simplified diagram of an atom, as you've probably learned about before. And at the center of the atom, you have the nucleus, which consists of neutrons and protons. And around the center nucleus, you have electrons, which orbit around the nucleus. The following table shows a charge on each subatomic particle and its location within the nucleus. So protons have a symbol P, and the charge on a proton is a single positive charge. It's found in the nucleus. The relative mass just explains how heavy the object is or the particle is compared to other particles. So as you can see, the relative mass of a proton is 1,836 times greater than the mass of an electron. And the mass of a neutron is about the same as the mass of a proton. Okay, so electrons are much, much smaller and take up a lot less space as compared to the nucleus of an atom. The periodic table lists all of the known elements in order of the lowest atomic number to the highest atomic number. The atomic number equals the number of protons found in the nucleus of the atom. So if you look on your periodic table, which has the following information, you should see in the top left corner of the element symbol, you have the atomic number. This number indicates the number of protons that are in the nucleus of the atom, and the periodic table is organized by atomic number. The atomic mass rounded to the nearest whole number is called the mass number. So in this case, the atomic mass for aluminum is 27. It's already rounded, so the mass number would equal the atomic mass. The mass number is just a simplified way of saying atomic mass rounded to the nearest whole number. The mass number equals the number of protons plus the number of neutrons in an atom. For example, aluminum has a mass number of 17. Therefore, the number of protons plus the number of neutrons in an aluminum atom equals 17. Okay, find the number of protons, neutrons, and electrons in an atom of aluminum. We can use the atomic number and mass number to find the number of protons, neutrons, and electrons in an atom of aluminum. The number of protons equals the atomic number, which equals 13. In a neutral atom, the number of protons always equals the number of electrons, so that's also 13. And the number of neutrons equals the mass number minus the atomic number. So that's equal to 27 minus 13, which equals 14 neutrons. So there you have. We can perform a final check. Protons plus neutrons must equal the mass number. So 13 plus 14 equals 27, which is correct. Try the following question on your own. Find the number of protons, neutrons, and electrons for an atom of oxygen. So at this point, you can pause the video and use your periodic table to do the calculation to see if you've understood the concept. Okay, so if we take a look at oxygen on the periodic table, the atomic number is 8, so it has 8 protons. In a neutral atom, the number of protons equals the number of electrons, so it's also 8. So it's 8 electrons. And the number of protons equals the mass number minus the atomic number. So that's 16 is the mass number minus 8, which is the atomic number, equals 8. So it just happened to work out to be exactly the same. It doesn't always have to be, but it's the same as the electrons and protons. In fact, oxygen is probably one of the only ones that is exactly the same, and it's 8 neutrons. So if you've done that correctly, you can move on. If not, you might want to go back and review. Okay, let's discuss the periodic table. Each row on the periodic table is called a period. Row is going from left to right across the periodic table. Each column going up and down is called a family or group. Metals are on the left side of the staircase and non-metals are on the right side. Metalloids are elements that touch the staircase. So if we take a look at this diagram of the periodic table, the first period would be hydrogen and helium would be the first two elements in the first period. This would be the second period. The third period goes across, so it goes across from left to right. Each group starts from the top and goes down, so this is group 1. And this would be group 2, and so on. Elements in the same chemical family or group have similar properties. Group 1 is called the alkali metals. They're very reactive metals. And it's listed on your periodic table. You can see underneath the group it says alkali metals on the very left-hand side. Group 2 are the alkaline earth metals, which are somewhat reactive. And group 17 are halogens, which are very reactive nonmetals. It composes of oxygen, sulfur, selenium, and tellurium. Group 18 on the very right side of the periodic table is the noble gases, which are completely unreactive. They do not react, and we'll talk more about why that is later. The block of metals from group 3 to 12 are called transition metals. So here you can see, just to go over what we talked about, the alkali metals are the first group. The alkaline earth metals are the second group. The halogens are the group with oxygen, number 16, group 16. These are the halogens. And then the noble gases, I'm sorry, I made a mistake. The halogens, excuse that, is not this group. It's the group with fluorine. So it's this group. This is the halogens. So I made a mistake there. It's listed on your periodic table, and the noble gases is the final group on the periodic table. That concludes the presentation. You can move on to the worksheet questions.